VL minus VC. So voltage across inductor is 242, voltage across capacitor is 163. So 242 minus 163. So your net voltage is equal to 78.5 volt. This is the voltage due to inductive and capacitive element. VR, this is the voltage across resistance, it is 62 volt, and this is the supplied voltage Vs, and phase angle we are found which is 51.8. so this phi will indicate the phase angle 51.8. so voltage across resistance, which is always in phase, voltage due to inductive and capacitive element, and as we are know, the inductive element is higher than capacitive element, so it is in upward direction. If Vc is greater than VL, then it is in downward direction. Okay, as shown in diagram, this is our VL 242, this is our Vc 163. so VL minus Vc, so your voltage is always in a upward direction. So this is inductive circuit, so this is our lagging angle. Now complex power, as we are know, complex power is denoted by S, and the unit of complex power is VA. VA is equal to volt into ampere, and complex means it has some real part and it has some imaginary parts also. So equation of S is equal to P plus JQ, where P is the real part of the complex power and Q is the imaginary part of the complex power, or you can say P is the real power and Q is the imaginary power for a complex form. So complex power unit is equal to VA is equal to real power, it is also known as the active power. So is equal to active power plus imaginary power, it is also known as a reactive power. So complex power is equal to active power plus reactive power. Unit of complex power is VA, unit of active power is W, means watt, and unit of reactive power is VAR. Reactive power is responsible due to inductive element or capacitive element. So complex power is also known as apparent power. If you are find the magnitude of complex power, so it is known as a apparent power, unit is remains same, it is VA, volt ampere. Now power triangle. As we are discussed earlier, three types of powers are available. One is the complex power, another is the real power, and third one is the reactive power. If you have to draw a triangle for a complex power, then it will contain all the relevant power information in a given load. Four pieces of informations are there. One is the apparent power, which is denoted by S. Second is the real power, which is denoted by P. And third one is the reactive power, which is denoted by Q. And again power factor angle, which is theta PF. So when you are draw the power triangle, you have to specify complex power, or you can say apparent power, real power, reactive power, and power factor. So this power triangle will show all the four parameters. If you have any two is given to you, the other two can be determined from the triangle using trigonometry as shown in figure. So this is the power triangle. Now this line will indicate the real power P. This is your reactive power Q, and this is your apparent power. This real power is related with the resistive element, so it is always on the reference axis. Q is the reactive power, it is related with the inductive or capacitive element, so it is always in vertical axis, maybe in upward direction, maybe in downward direction, depends upon the circuit elements. If inductive element, then it is like this. If it is a capacitive elements are more than inductive element, then it is goes in downward direction. And S is the apparent power, and this theta will indicate the power factor of the particular circuit due to resistive and inductive elements. And this is the impedance triangle. if you are refer this two, then both are same. This is P, means the real power due to resistive element. So in impedance triangle, here it is resistance, always on the reference axis. So this is our R. This Q is due to inductive and capacitive element. So here it is X, maybe XL, maybe XC, depends upon the circuit elements. So this is our R, this is our X, and this is our Z. This is complex power or apparent power, which is combination of P plus JQ. Here it is impedance, it is combination of R plus JX. So if you are compare these two, then you can say real power is related with resistance, reactive power is related with reactances, and apparent power is related with the impedance of the circuit. So this is the relation between power triangle and impedance triangle. So this is a power triangle for lagging power factor and leading power factor. As we had discussed earlier, same way you can draw a power triangle for lagging and leading. Method is same. Again, this is P, which is on the reference axis because it is due to resistive element. Then this is your plus Q. Plus Q means it will indicate that your circuit having inductive nature, and your power factor is lagging power factor. So your Q will goes in a upward direction, and this is our S, means apparent power. Same way P remains constant, maybe it inductive or capacitive behavior of the circuit. Your P is always on the reference axis, but your Q will change. If it is inductive, then it will goes upward, but if it is capacitive circuit, then it will goes downward, and it is denoted here by minus Q, and your power factor is leading power factor. Again, this is your apparent power S. So whenever your circuit behavior will change, lagging to leading, according to that your reactive power will change, and due to that your apparent power and power factor will change from lagging to leading. So this is the power triangle for lagging circuit, or you can say inductive circuit and capacitive circuit. This is power triangle and impedance triangle. Same way as we had discussed earlier, you can relate this each other. Now equations of various power. As we had discussed earlier, basically three types of power are there: active power, reactive power, and apparent power. So P is denoted by, P is known as active power. It is also known as true power. As we had discussed earlier, this active power is related with the resistive elements only. So P is equal to I square into R, where I is the current passing through the circuit and R is the resistance of the circuit. And you can rewrite this equation like this: P is equal to E square by R, where E is the voltage applied to the circuit and the unit of true power or real power is watt. So if current is given to you, then you can use this equation: P is equal to I square R. If voltage is given, then you can use this equation: P is equal to E square by R, to find a real power or true power. Now second is the reactive power, which is denoted by Q, and it is due to inductive or capacitive elements. So equation for a reactive power Q is equal to I square into X. X is the net value of reactance, so you can find it by XL minus XC or XC minus XL, depends upon the circuit behavior. So in general, you can write the equation of reactive power like this: it is I square X. If it is RL circuit, then Q is equal to I square XL. If it is RC circuit, then Q is equal to I square XC. So it is depends upon the circuit elements. And again you can rewrite the equation in voltage form like this: Q is equal to E square by X. So if current is given, you can use this equation: Q is equal to I square into X, and the unit of reactive power is VAR. Third one is the apparent power. It is denoted by S, and as we had discussed earlier, apparent power is related with the impedance of the circuit. So equation of apparent power is I square into Z, and rewrite this equation in a voltage form like this: it is E square by Z, and the unit of apparent power is volt ampere, VA. So these are the three powers: real power, reactive power and apparent power, and you have to find the value of this in the particular example. So if current is known to you, you can use this equation: real power is equal to I square R, reactive power is equal to I square X, and apparent power is equal to I square Z. So whenever you have to find the value of power, first of all you have to find the reactances XL and XC, and from this XL and XC you have to find the impedance of the circuit, and then you can find the real power, reactive power and apparent power for a particular circuit. Now one example is given. One circuit is given to you. Supply voltage is 120 volt and frequency is 60 Hz. This is a purely resistive circuit. Current passing through the circuit I is equal to 2 ampere, and the value of resistance is 60 ohm. Now as we had discussed earlier, your real power is equal to I square R, reactive power is equal to I square X, and apparent power is equal to I square Z. So now in this particular circuit only resistive elements are there, no reactive elements are present over here. So for this particular circuit, your real power P is equal to I square into R. Value of I is given, it is 2 ampere, value of R is given, it is 60. So it is 60 into 4, so your answer is 240 watt. Now what about reactive power? Reactive power is equal to I square into X. Now in this particular circuit, no inductor, no capacitors are there, so X is equal to 0. So your reactive power I square X is equal to 0 VAR. Now what about apparent power? Apparent power is equal to I square into Z, and Z is equal to what? It is equal to R plus JX. Now here X is not given, but R is also already given to you. So your apparent power is equal to I square into Z. So it is same as a real power, but unit is VA. So here it is 240 VA. So this is the example of resistive circuit and how you can find the real power, reactive power and apparent power for a resistive circuit. Now one more example is there. One more circuit is given to you. Again supply voltage is 120 volt, 60 Hz. Value of current is 1.410 ampere. Inductor is given, it is 160 millihenry, and value of XL is already given, it is 60.319 ohm. Value of resistance is given, it is 60 ohm. Again you have to find the real power, reactive power and apparent power. So your equation of real power is I square into R. Value of I is given, it is 1.41. Value of R is also given, it is 60 ohm. So your real power is equal to 119.36 watt. Now reactive power. For reactive power you have to find the reactance. Reactance is already given in the data. So it is equal to I square into X. So it is 60.319 into I square. So your answer is 119.998 VAR. This is your reactive power. Now apparent power. Apparent power is equal to P plus JQ, or you can write down I square into Z. Value of R is known to you, value of XL is known to you, so you can easily find the value of Z using the equation Z is equal to under root of R square plus XL square. So using this equation you can find the value of Z, and after that you can find the apparent power, and answer of this is equal to 169.256 VA. So this is one more example in which we are finding the real power, reactive power and apparent power. In resistive circuit, your reactive power is 0. Whenever inductive or capacitive elements are present, your reactive power having some value according to the value of elements. Now one more example is there. Find reactance, impedance, total current, power and power factor for a given circuit. Circuit is given to you. Value of resistance is 4 ohm. Value of inductor is 27 millihenry. Your voltage is 110 volt and frequency is 50 hertz. Value of capacitor is also given, it is 380 microfarad. So this is one of the RLC series circuit, and this particular circuit you have to find the impedance and current passing through the circuit. So first of all you have to find the inductive reactance and capacitive reactance for a given circuit. So frequency is 60 hertz, value of L is equal to 27 millihenry, value of capacitor is equal to 380 microfarad. First of all you have to find the inductive reactance XL, and equation for XL is equal to 2 pi f into L. F is equal to 50 hertz, L is equal to 27 into 10 raised to minus 3 Henry. So if you are put the values in this particular equation, so your final answer of XL is equal to 10 ohm. Same way you have to find the capacitive reactance for a 380 microfarad capacitor. So XC is equal to 1 upon 2 pi f C. So it is equal to 1 upon 6.28 into 60 hertz into 380 into 10 raised to minus 6 farad. So your answer is equal to 1 upon 0.143 ohm. So your final answer for XC is equal to 7 ohm. So this is your inductive reactance and capacitive reactance for a particular circuit. Now you have to find the value of total X. XC is equal to 7 ohm, XL is equal to 10 ohm. So it will indicate it is inductive circuit because XL is greater than XC. So our final value of X is equal to XL minus XC. So 10 minus 7. So our answer is 3 ohm and it is inductive circuit. Now use the value of X to find the value of Z, which is the impedance of the circuit. Now net value of X is equal to 3 ohm, value of resistance is 4 ohm. Now equation of Z is